welcome everybody. Thanks for attending this session. And I'll talk about hexagonal architecture and monolith decomposition in web payments. So this leads me to a bit about me. So I'm a senior software, this as well, right? So I'm a software engineer at Ocado Technology, a global player in online grocery store. And I work in payments domain, and we had a challenge we had our microservice that were getting too big, and we decided to decompose it. We decided to make it better. So this talk is going to be about this decomposition, how we are approaching the techniques we are using, and luckily you can take inspiration and apply in your day-to-day as well. Even though this talk is how we are doing in the payments domain, it's important that you note that it's not related to payments. So the architecture itself can be applied to any domain, like for the ones who know hexagonal architecture, you know that's a agnostic approach. Of course, it's nothing to do with payments. So it's just the payments here is a bit of context, and it's our domain. So I think it's important just to make this contextual thing, and some challenge that we had, some characteristics of our software may not apply to your day-to-day. If you want to know more about Ocado Technology, you can follow this QR code to know about our company, and we are hiring, and feel free to open this QR code and see what you got for you. Okay, so in this session, I will mainly divide in three big parts. First, an overview of our current architecture, how payments looks like for us. Then, and its difficulties that we have also are in this part. And then the chosen architecture style, how we are improving this microservice. And then a later step, the next stage is how we are doing this in a continuously manner, right? How in practice looks like. Okay, so payments, let me just open a laser point. Okay, so we manage a large number of microservices in the order of a dozen, but we can pretty much summarize our high-level architecture, our system architecture, into three main components. Payments web service, that's a microservice. Then we have workers and payment service provider facade. So this talk is only focused on payments web service, on this microservice. It's our main, let's say, our main monolith, where all the business rules, the most heavy business rules are located. This microservice is responsible for generating the financial transactions, right? The charges, how we are going to charge a credit card. So if it's valid to do a refund, to do a authorization. So the heavy payments logic is in this microservice. And the way it actually makes effective these financial transactions, how we effectively talk to the bank, is in a asynchronous manner, pushing workloads to queues, to SQS queues, that we have workers constantly pulling these queues and processing these transaction messages and effectivating them on the payment service providers, right? It's a very high level. It's not key for the presentation, but it's just for you to get a contextual idea on what we're talking about. So the architecture we are focusing here, it's a intra microservices architecture. It's not a high-level system architecture. It's not the architecture mentioned here won't be touching multiple microservices. It's just inside one monolith. How we are making one monolith better to work, better to evolve, and how we are pushing our code base to better standards, right? So, well, a few styles that lies around the payment web service are, we can summarize, it's a monolith, right? in contrast what a modular monolith could be. So it's a microservice of those good old monolith without clear boundaries inside. It is structured in a layered architecture approach, right? So we get more into that soon. And it's also using what is called the transaction script style, right? What Martin Fowler also referred in these patterns of enterprise application architecture. It's the lack of object-oriented principles. So it's popularly known as a big ball of mud, right? The combination of these facts equals big ball of mud. So our challenge is to get this monolith with these symptoms and improve it, make it in a way that we can work faster, right? So this is the goal. This is the focus of the talk. It's not high-level architecture. It's not system architecture. It's just focused on a microservice. So this is style, right? So it's three symptoms: a layer architecture, a service layer with transaction scripts, and a monolithic style. What we mean by that? So the layer architecture, it's the most common way, at least possibly in my opinion, most common way of developing software. It's how we are teaching in university, how we see those tutorials. And it's when you have layers, you divide your software into layers that they are focusing on the technology. They're not focusing on the domain. So you have layers, packages, right? Controller, services, DAO, exceptions, all sorts of technology layering. It's how you organize your software. And this has well, an extent, it's a variety of drawbacks that is in the literature, probably most of you are aware of. But just to name a few problems with layer architecture is that by the high coupling between the layers, it's very hard to test each layer independently. It's very hard to make unit tests, mainly, that are isolated, right? It's very hard to test the domain separation because you have the burden of the layers attached to it, right? There is no good abstraction between one layer and another. They are directly referenced, right? Switching infrastructure is also, for the same reasons that's hard to test, it's very hard to switch infrastructure. If you want to change, the common example, if you want to change your database, it's going to be a big effort because you need to change a lot of classes on the layers above that are coupled with this layer below the infrastructure, right? So it's like the infrastructure knowledge ripples to the other layers, right? Yeah, these are just a few that we could say. On the service layer, it's I will get more into that soon, but it's generally when you have your domain logic spread through a number of classes, and you don't follow ideas from object-oriented principles. You try to put all the logic in one class, and right, without following a good modularization, a good separation of concerns. Martin Fowler has a good chapter on this on his book, Pattern of Enterprise Application Pattern, and we're gonna get more into that soon. And to finish the monolithic style, we want to still keep it monolithic for a while, but we want to move for a modular monolith, that we have a more clear boundaries in microservices, right? So feature flags. I know it's deviating a little bit, but it's important. So who from you are familiar with feature flags? If you are, comment on the chat. So feature flags, it's a powerful technique. It's also very old, also referred as feature toggles or toggable features or just flags. So it's a technique that you place generally Boolean flags in your code to make your software behave differently according to a certain criteria, right? So flags are used in a variety of ways. And it's really good. I mean, it's really good. We use it extensively in payments. But the thing is that flags introduce complexity naturally. If your software will behave differently, right? If you have multiple ways of achieving different behavior in the same code base, naturally you increase complexity. And why is important that I'm mentioning this here? Because in payment, the microservices we deploy to the cloud, right? To AWS. But we have each client from us, each client that buys our platform have a different AWS environment, and they want different behavior. So one country, for certain clients, they want a flow of payment, like reserve the money at checkout and charge the money when the order is delivered, for example. Another client wants a different money reservation flow in a different moment. Another client doesn't want any money to be reserved. So I'm adding here a few payment concepts, but the important takeaway is that there are a variety of different flows and different behaviors that we need to support with just one code base. So we mainly use feature flags for achieving these different behaviors and to achieve what's called a dark launch. So dark launch is just a fancy name the intent of dark launch is to be able to work with trunk-based development, right? So be able to push your code to production, your feature to production without it being completed, right? So to avoid those long-lived branches. So we apply this technique. Developing a feature, and I want this feature to be available for 10% of our customers, right? So this also falls in the ideas of dark launch or canary release, A/B testing, multiple techniques lying around these concepts, right? So okay. So we know that feature flags are present. They are here to stay. We have many of them in our code base. So this is an important characteristic that we need to keep in mind when restructuring a monolith, right? 1 second. Okay, so service layer based development. This is one way that I'm particularly calling out the service layer with a transaction scripts approach. Honestly, this is not a official terminology by any sense. It's just a name that I came up because I'm pretty sure that you also have seen that in your career with when you are developing a code base and you are using Spring, for example, or any context and dependency injection in any IOC container. It's very easy to inject dependencies around, right? So it's very easy for you to have a class, service A, that does some behavior, then it calls service B, then it calls service C, and service B calls another service. So, and when all the logic, it's only in these service classes, you don't leverage a common domain core. And these services are tied together using dependency injection. The way I like to see, and if you can picture that together with me, is you have a software which is very procedural, right? It's a procedural style. And it's like you have a big file. The only difference is that you are spreading this into a few key classes, but you are like tying them together. It becomes this net, this mesh of service classes, right? And it's common to see in these services multiple functions, many public functions, and even more private functions, because everything is done there. Large number of dependencies, large number of collaborators. The use cases of the software become hidden because, well, you see a public function being called from a controller, but this public function can also be called from another public function in another service. So we have one entry point that is being called by multiple places, and you think, okay, but what's the structure of this software, right? What are the use cases? Because I cannot simply say that every public function will be like a use case because it's used in different manners. Right? Maybe it's using in a variety of different use cases. Maybe this is a bit abstract now for you, but I hope it will become a bit more clear. So we want something that has a better structure, right? We want something that describes the use case of our software in a way that the programmer just opens the project and can see all the use cases faster, and the code has a proper place to be put in, right? Robert Martin, Uncle Bob, calls it screaming architecture, right? When your architecture is screaming its intentions. And with this service layer-based development, we don't have it, right? So sorry for the amount of code. Don't pay much attention exactly for each word. Try to pay attention to the structure of this file, right? So this is a payment service. It's one of our service. By the name, you can guess it's probably one of the most important in the payments microservice. So that's the thing, you know, even the names are quite generic, right? So what exactly a payment service class, which is a natural name for you to pick when you are working without a clear structure, when working a service layer-based development, what exactly is a payment service responsible for? Oh, it creates a payment, it updates a payment, it deletes a payment. Well, okay, but if create payment is called in multiple places, for example, create payment is called from a controller on a post method to create a payment, right? It's a create payment use case. But this could also be called from another service, you know, another service that at some point needs to create a payment as well. So now you have two entry points that calls this create payment, and this structure starts to grow more and more and more, and your software just becomes this big ball of mud, this big mesh of relation without a clear structure, right? Also, note the number of collaborators here. I have a bunch of servers here: validation, transaction, DAO, converters, feature flag services, calculation services. So this high number of collaborators make it really hard to reason about, and it makes really hard to test. You know, it's like you need to read a file with 1,000 lines, and it's become even harder to test, and for a variety of reasons, hard to evolve, to work in parallel. When you look to this function, you see these if conditions. Remember, I'll say about feature flags. So the way we check feature flags, it's through a service. Why not, right? So there is a feature flag service that tells you if the feature is enabled. This feature flag service will end up reading files, YAML files, but that's not important. So let's take this example where there is a authentication factor, not entering too much in the payments nomenclature. That's not super key, but imagine that when creating a payment, there is an authentication scheme that you need to follow. And we always have been working with this good old scheme authentication, right? We always call this method 3D secure service, good old authentication. This is payments nomenclature. But now there is a new way. It's a new scheme. That this new scheme, it's maybe just one client that wants it, or maybe it just came out a new standard, and we need to slowly implement this authentication. So what we do to make ourselves more safe, we create a feature flag and we put this new scheme under a feature flag, right? And it will only be executed in certain moments when the feature is enabled, certain environments, or programmatically using percentage of access, or any strategy, right? But what's the problem here? In thinking about cohesion, right? Cohesion and coupling. Immediately you see that there is a high coupling between payment service and 3D secure service. There's a high coupling because not only payment service is calling 3D secure service, it also needs to know two functions. It needs to know that I need to call new scheme authentication, or I need to call good old authentication. I need to know that these functions exist over there. And I'm not only depending on these functions, I am importing the full service, right? So 3D Secure service, a service responsible for authentications, is likely to have many, many more functions, public functions there. It just happens that this service in question, payment service, is just calling 2 functions, right? But at the same time, is depending on the whole object. So this is all about coupling. It's all about coupling and cohesion, right? So how can we make it better, right? How can we evolve this payment service to look something more useful to us, right? So now I will enter in the chosen architecture style. Okay, so I have exposed the problematic to you. Now I will expose the styles that we want to apply. And so a way to picture this is we have these 3 symptoms, right? So because this is important, this migration is not one big symptom. It's a variety of symptoms, right? I categorized in 3 symptoms: a layer architecture, the service-based development, and the monolithic style. How we are replacing them with this new re-architecture approach is we are going to leverage hexagonal architecture, more on that in a minute. We are going to use a technique called the use case layer with domain model. And the monolith will become a modular monolith, right? So it's a one-to-one replacement. Layer replaced by hexagonal. Service layer transaction scripts replaced by use case and domain model. Big chunk monolith replaced well-organized modular monolith. This could not necessarily be done all at the same time, right? It could be done different. We could just change layer architecture to hexagonal and not necessarily change those service layers. So that's important for you to keep in mind. That's a few fronts that are being attacked here in the goal of achieving a greater deal, right? So hexagonal architecture was introduced by our great author, Alistair Cockburn, in 2005. He was like having these ideas many years before, but ended up posting it just in 2005. And he says that he wants an architecture, an approach that allows an application to be equally driven by users, programs, automated tests, or whatever actor is running the application, right? The application needs to be tested in isolation from its eventual runtime devices and database. So this classical author phrase. But this guy came from a time where, this layer architecture really coupled together. And he was working in a project. He mentions that the project was super coupled to a database, and he was not a computer. He was more involved with low-level things, not super into object orientation and things like that. But he got mad that he was not able to test an application, right? Some people without interacting with the database. People say to him that it was impossible because the application was so coupled. So then he came up with this hexagonal architecture, right? This idea of decoupling your domain code from the eventual runtime that is being run. So I made a draw here for you. Hope I'm not good at drawing, but let's see. So hexagonal architecture, I have drawn it as a circle, just because hexagonal is not really necessary. Hexagonal is just hexagonal was just a shape that he wanted to use, but the architecture does not relate with the shape, right? So on a layer architecture, the normal style to develop applications, just close this. We think in our application into layers, right? Into multiple layers. So it generally will be 3 or 4 or whatever number of layers. When we think in hexagonal architecture, the concept is really a different approach, a different way of seeing. There is no more layers anymore. There is just inside and outside. It's simple as that. It's just this view. It's either inside the hexagon or inside the circle here, or is in the outside. Right? What is in the inside? Well, the inside is your domain code and code that needs to support your application, that needs to always be present. Right? It's the thing that pays your salary, let's say, but not super true, but let's say it's your core thing, what you do different. The inside is what your team does different. The outside is everything that needs to be in place to support the application to actually do something, right? So the outside is the infrastructure. When we think about an HTTP request, it's being handled by a controller. This controller we call the inside of your application. Your application will do a query in a database and return the response. If it's interrupting me. So if we think about the controller, it's not a key thing in our application. The controller is just an infrastructure that is there to receive an HTTP response. The important thing is on the inside. So his idea to decouple the important thing that you do from the external thing that is just there to support, it's placing the so-called ports abstraction, right? The proper name to hexagonal architecture is in fact ports and adapters, because it's a design pattern, right? The ports and adapter it's on top of the adapters patterns from the Gang of 4 book, and it stipulates that your core won't know anything from the outside. You just talk with interfaces. You just talk with ports. So this way, when you are testing your application, remember his main motivation was to test the application. The unit test is nothing more than a different driver. The application doesn't know that it's being run by a unit test, but a unit test will call an input port, right? Also called a driver port, and will provide mocks to the output port. So this way, your port could be implemented, let's say in a repository, could be implemented by a real repository or by a mocked repository. It makes very, it makes a lot of sense to be mocking infrastructure. And why we are going with hexagonal architecture, right? Because infrastructure for us, it's something that is constantly changed for everybody. But not only we need to replace infrastructure, we also need to support multiple infrastructure in its eventual runtime. There are some certain clients that want a certain payment gateway. Other clients want another. Some clients we need to call some certain REST client, REST client to call some microservice. Some other, in other environment, we need to call a different set of microservices. So it's in a highly customizable environment. If you are developing for customization, infrastructure customization, it's really hard to achieve your goals with a layer architecture, right? You need to look something like hexagonal architecture, where you can swap on demand, right? So in the inner part, so hexagonal architecture is not about placing components. It's not about, it's nothing to do with domain-driven design, object-oriented, or any other principle. It's just about separating infrastructure from application, from domain, let's say, right? But how we are going to organize our inside? We are going to use the so-called use case in domain model. It's a use case-driven approach. But it's important to note that we could use different types. We could use, for example, domain of actors using a actor framework. We could use a functional core. If imperative shell is when you're heavily relying on functional code, or we could go for something like a domain-driven design. But or we could simply stay where we are. We are this one service layer based. We could stay, but no, we are going for something that is more classic, let's say, or at least a bit simpler to implement. Is my opinion, because our team is not familiar with these other techniques. And okay, so what is a use case, right? A use case in the domain model. So a rich domain model, you go from a anemic model of objects with getters and setters, and you start placing behavior on them. You start making your objects more smart, right? Your business rules won't be in services anymore. Your business rule will be inside your smart objects, in your domain core. So your important stuff is in this core, the domain core, the same as you would have in aggregates in domain-driven design, right? It's not really one-to-one, but more to give the idea, right? And the coordination are the use case. So these yellow boxes here are the use case, right? A use case will coordinate a domain core. If any one of you is familiar with clean architecture from Robert Martin, it's similar to a use case there. I'm not necessarily, I wouldn't say it's 100, but similar. And the idea of a use case, because we are replacing service classes for use cases, the idea is that we favor single responsibility principle over code reuse, right? With those large service classes, it's simple to be reusing private functions, and it's easy to fall into the bad code reuse. So when there is a private function that does something similar to what you want, but not quite, then you put a Boolean flag, should do something, and you start passing these Boolean flags to private function to achieve generic behavior. So this is a bad code reuse. Use case tends to decrease that, because every use case cannot use another use case. So a create payment use case is a create payment use case, and all the functions there will only be used by this use case. If you want to share behavior, you need to pull this behavior to a domain core. But then you need to make more conscious decisions, right? It's harder to mess up. And also, these use cases provide a common entry point. It's faster to know what are the entry points of my application. I don't need to look infrastructure, right? When you are working this layer architecture in those large service classes, if anyone asks to you, what are the functions that your software does? At least me, what I do is I go to controller class. I go to REST controllers and queue listeners, and I see all these entry points, right? Because I cannot trust the large service classes. It's harder to unveil the mesh, right? So the entry points, I need to go to the infrastructure to locate the entry points. This approach, no. This approach, I can ignore the infrastructure. All the entry points are just a use case. So it provides a clear structure, a clear semantic, and something that we can reason about, something that we can talk about. Again, goes into the screaming architecture idea from Cobalt, right? It's given semantics. So we have done it, these two parts. Now we are heading to the end. I know you're probably tired of listening to me. So this section is about this section is about how the monolith it's being transformed to this new style, right? So again, the same payment service as before. It's the same picture. Let's make this a more cohesive class. Let's make it more cohesive along the lines of what we discussed, right? Let's transform this payment service into one use case, right? Which use case will be? Let's take it, create payment, right? That is a public function. Create payment seems a good candidate to convert this to a use case, a create payment use case. Look the size it will become. Just this, right? If remain just 3 collaborators, important. No other functions here. So here we have update payment, delete payment. these are different things. No, we just place create payment use case in one class. Where are those if conditions? Where is that coupling? Where is it went? Where is it went to? Right. So this high coupling, this high knowledge here, we have hidden behind the port. Right. This whole block if condition that it's hard for us to reason about. We have converted to a clean interface authentication port. It's so cool that we even introduce a new concept that we can talk about. Now, when I'm reading create payment use case, oh, I just read that it needs to authenticate. And then it needs to get the next identity. If the identity like let's say the primary key, the ID of the payment, before I had an if, because multiple clients have different ways of doing identities. But now I don't need to care about that, right? If I want to see different ways that our software authenticate, I can still, but I need to go to other place. The cognitive load, right? When I'm reading this code, I have to keep less things in my head. The cognitive load is lower, right? Because when I'm reading this procedural code, I'm just caring about creating the payment, but I'm forced to read more things. I'm forced to see a feature flag. I'm forced to see different schemes. I'm forced to see different key generator schemes. It's like mixing a lot of concerns. I just want a flow, a receipt. And this is what the use case does. The use case is just the flow, the coordination. And this is the interface authentication port. It's a port from hexagonal architecture, but we still need to execute the original function, right? We still need to call the authentication function method. How is done? Well, it's the adapters, which it could be a bean in Spring, right? So this is a Spring bean. So I have two adapters: the new authentication adapter and the old authentication adapter. Just a method reference to the old code. This is in runtime, it will be the same thing, the same function being executed. The difference is that I have moved these concerns to another place. The if condition will be in another place. So this is pretty much a strategy pattern, right? I'm applying a strategy pattern in a architectural level. I have different strategies to authenticate. The use case doesn't need to know anything about, right? So it keeps things way cleaner and way nicer. Now we can talk about authentication like it's a living thing. It's a first-class citizen in our architecture. Wrapping up everything, a bit of a dense image. Hope that it can help. So what we have done, we have extracted a create payment use case, which just cares about the interface authentication port, right? This is our domain. What will be the authentication is the adapters. New authentication adapter, good old authentication adapter. This lies on the infrastructure part. It's not concern of the domain, right? And these adapters are calling the authentication, the 3D secure service, which we can treat as the legacy part, because remember, we are extracting this in modules. So we have a monolith with everything. Now we extracted the use case into a clean module. We are initiating this modularization. And these adapters will be a bridge for us, right? The adapters it's like we are moving to this new idea, but we need to use the old code. So we have this bridge that are the adapters in hexagonal architecture. It's just a nice way of using the ports and adapters idea. I didn't mention the use case factory, but at some point, the if condition for the feature flag still needs to be done. And it's done when the factory that creates use case, right? So the use case is not a bean. There is a component that creates it, which is the use case factory. Finalizing one of the last slides, So this migration from large service classes functions to use cases, it can appear different patterns, So the first one, very simple pattern, is when you have a function, just a public function in a large class that doesn't have feature flags, doesn't have anything, it's simple. Okay, straight away becomes a use case class and with some certain adapters. So the calls to collaborators that are in the function just becomes calls to ports that are resolved by adapters. The second is what we done now, what we have done in the previous slide. When you have a function that has a feature flag, right, that defines some infrastructure aspect, like one authentication or another. So this is the second case, becomes a one use case with two possible adapters to be chosen from that need to be evaluated against criteria, right? But you can have other situations that I didn't show and that they can appear. You can have a function that has one feature flag, but this feature flag defines certain big, it's such a big characteristic of that function that you may extract two use cases. Imagine that you have a create payment function and then the one we had now, but then you have an if condition that checks the region you are. I am in Europe or Latin America, just making up an example now. If you are in Europe, the create payment functions calls a create European payment. If you are in other place, creates Latin American payment. That is probably quite different functions, and quite different functions, even they are, so create payment functions can lead to very different ones. In this case, probably would be better to introduce two use cases, right? So again, we are introducing a strategy pattern on a use case level, powerful technique. Here we introduce a strategy pattern on the adapter level, here on the use case level, but we can also have a more highly customized option, which is when your function does so many things. I hope that we don't find this sort of functions because the original function would look quite complex, but a function can become multiple use cases. And sorry for this, this thing here. So the function can become two use cases, and each use case can still be multiple adapters. So this is like strategy pattern on steroids, right? Two levels of, so, but this shows that the proposed architecture, the architecture we are using, allows for highly customized scenarios. And it's done. Takeaways that we get, just select the few phrases. The takeaway that we get is that we can evolve gradually. We don't need to do a code freeze. We don't need to stop all programmers. We can evolve architecture slowly. It's hard. It needs to constantly be evaluating it, but it's possible. We can have multiple infrastructures at the same time in runtime being decided in a variety of ways. Then we leverage hexagonal architecture for it. Use cases, they provide a good single responsibility principle, even though there will be some code duplication. If the code duplication should change for different reasons, there are benefits with it, right? So it prevents the bad type of generic code. And last but not least, not all that I mentioned need to be migrated at the same time. These styles, they don't need to be applied together. They are parallel styles, right? We can use hexagonal with different inner core applications, and we are heading for a modular monolith, but we could head for microservices right away also. Yes, I think that was all from my side. And if you have any question, I plan to post an article on Medium. So if you if you happen to follow me, maybe you can receive a notification the next days with a more detailed description on and code samples, how we are doing it. Well, thank you a lot for your time, and that was a long session. Thanks.
Thank you so much, Johnny, for the talk and for the insights. There's coming a question, sorry. Johnny?
Wait, sorry.
Yeah, in
yes.
the chat, some questions.
Oh.
Sorry.
I thought you would read. Now I did.
But no.
No. Let me see how I'm going to do it.
Or I can read them also to you if that's easier for you.
I would appreciate, because I'm like multiple screens here going back and forth.
Of course, no
if
problem.
You can read.
So the first question is, how is your folder structure looks like now?
I'm so like, okay, how is your, okay, my folder structure is, okay, I don't have any slide here. Modular monolith, right? So currently in a monolith approach, right, the legacy style, package by layer, right? The controller, exception services, normal, packaged by technology style. Now with modular monolith, we start the packaging with let's say a domain context, a bounded context. In this case, payment, for example. Inside this package that represents the module, it will have two separations: domain, infrastructure, right? Domain, infrastructure. The domain will have the use cases and the ports, the output and the input ports in hexagonal, right? So it will have in the domain we have everything that we have here: input ports. I think you can see my screen, right? Output ports and all the classes to support it. On the infrastructure package, we have all the well, there are further divisions on some listeners. There are still some separation on the infrastructure, but what is important? First row of packages, bounded context, then domain, infrastructure for each one. Right? Each module, it's a hexagonal architecture apart. Right? Everything inside a microservice, right? But what we can take, if any one of these modules, we can extract to a different microservice. So it's like if we would have microservices, just we are deploying them together. Yeah. Sorry for not having a picture of this actually. Any more questions? Let's see. Really enjoy. Thank you very much for the people who enjoy. Thank you very much. On low service level, we often have use of private function. Before gets extract the use case, how can reusage be solved? As those often refer rather utility functions than domain specific. Okay, that's a great question. That's a great question. Reusing functions, it's people tend to like reusing code a lot, right? We like to apply dry at the first moment that we can, right? Don't repeat yourself. From my personal experience in our team, and I'll talk for other things, there are a lot of reusing that goes to extreme. You see a function, you want something similar, you want to use that function, then you start putting parameters. So with use cases, there will be some overlapping that you will duplicate code. There will be some code that won't be reused, right? And this is okay if they need to change for different things. Now, when there is for example, a calculation of a taxes, we won't duplicate a calculation of tax. But it's not the use case that will do a calculation of tax, the code. It will call a domain object in a domain call. And this domain object can be reused by different use cases. The idea of use case is just it defines the flow and it coordinates this. It's what in domain-driven design would be the application service. right? So great question. And there are other techniques that also we use. For example, not going into that, but we want at every use case, we want to push analytical events, right? Upon starting the use case, we wanted to send the analytical event to New Relic and monitoring. We didn't feel that placing that behavior in the use case was the best because it would simply be duplicated at every use case. In this, we created a decorator. So you can create a decorator pattern that does behavior, and it decorates your use case, and this becomes an infrastructure decorator, for example. So there are other techniques. You didn't suggest to deploy each adapter as a separate microservice. No, adapters are classes in infrastructure. A adapter will maybe call another microservice, but adapters live inside the same application. These adapters are this, right? Event handler, event publisher, because your port will just be send event. Your domain wants to send an event. Okay, will I send an event to SQS? Will I send an event to Kafka? Will I store this event in a database? That's different adapters. One adapter for Kafka, one adapter for database, one adapter for SQS. Which one I choose depends on the runtime, right? There will be a place in the factory, the use case factory, that decides which adapter should I provide to that use case. I can use all three in runtime, but that's fine. Yeah, the microservice is a bit tricky because I started with microservice, replying to Peter here, but actually the talk is just inside one microservice, and thanks for the feedback on that. If there is a good code sample on GitHub, not yet. As I mentioned, I'm writing an article that will put everything into more detail and different trade-offs. There are other concerns that were not mentioned, and then I will create a sample. But unfortunately, well, the slides here are code that I got inspiration from our own. So it's not something that I did a side project yet. Hopefully, thank you. Is there a good public and complex enough example for Hexagonal? From Serafina. Well, there is a website that Alistair Cockburn himself recommends quite a lot, and I think that there are samples there. So it's Hexagonal me. Yes, this is recommended by the creator itself. So it's I think here you can find good resources, or at least a point indication to where you can look. Okay, thank you.